Okay, polar coordinates. Polar coordinates, you're given the radius or distance from the origin and the angle in standard position. As you can see right there, we're going to do 4 different things. We're going to find 2 other ways of representing the point, specifically with a negative radius, and then one with a negative theta. We're going to plot the point. I'll discuss all 3 variations, and then we're going to convert it to rectangular, which is just normal xy. Okay, so for starters, on Blackboard, I do have this game. Another teacher put it together. It's pretty helpful, so you might try it. I do suggest that just play around with the 4 variations that you see there and experiment. So every point has 4 basic variations, which you can then expand with all the coterminal stuff. But normally we try to stick with 0 to 2 pi or negative 2 pi to 0 for negative n. You don't. Okay, so for positive theta and negative radius, we are going to take the radius, put a big old negative in front of it, and then take the theta, and depending on whether we want the answer positive or negative, add or subtract pi. So in this case we want it positive, so we subtract the pi, 7 pi over 6 minus pi, pi over 6. There you go. Part B, we want the angle to be negative and keep the positive 4. So part B down here, positive 4, and this is just coterminal. So we take that 7 pi over 6, subtract the 2 pi, negative 5 pi over 6. All right, when we plot the point, no matter which variation of the coordinates that you're given, you start with the angle. At least this is how I do it. You start with the angle and then let the radius tell you what to do. So for the original point, 4, 7 pi over 6, we just find the angle in standard position, 7 pi over 6, quadrant 3, and the positive 4 says put the dot right there on the 4th circle, radius of 4. If we were starting with the part A answer, where the angle is pi over 6, that would be in quadrant 1. And so the negative 4 then says, oh, we'll put the point over here in the quadrant opposite, which would be quadrant 3. And we get the point in the same position. The part B point, start with the angle. It's negative 5 pi over 6, and put the point right there. So any of these variations gets the same point in the same spot there. And the last part, convert to rectangular. This is our SOHCAHTOA. X is the radius times cosine. Y is the radius times sine. The radius is the hypotenuse or the magnitude, different things. This is a unit circle. So 7 pi over 6, quadrant 3. The values for x and y are both negative. Pi over 6 reference angle, sine gets the small number 1/2, cosine gets the large number, square root of 3 over 2, multiply, simplify, write your answer as you see over there on the right side. The next example starts with the rectangular, x and y, and we want to write it as the polar. 2 different ways, r positive and theta positive, and then r negative with theta positive as well. So r, Pythagorean theorem. Be careful with the calculator. If you type it in exactly as I have here with the parentheses, you can't go wrong. If you mess up the parentheses in some way, you could get a lot of different incorrect answers. So be very careful with that. I always recommend if you use the calculator with the inverse that you just make those x and y numbers positive. And don't worry about the negative until the next step. Now this is a unit circle value, and we've done this quite a few times in previous lessons. But always assume that's your reference angle. So to get the actual angle we need, x is positive, y is negative, that's quadrant 4. So this will be 2 pi minus the reference angle, pi over 6, 11 pi over 6. You see my answer right there. So for the next part, we want to change it so that we can have a -6 for the radius, which means the angle has to be in the opposite quadrant. So 611 pi over 6 is in quadrant 4. You can see the point right there. So we'll need the angle in quadrant 2, which is 5 pi over 6. You can see I just subtracted the pi to get it. That is coordinates, and we're done.